Hi everyone, this is the NFT sales forecasting literature review. We are a team of three, Can, Malte and Julian, myself. We are working in the machine learning program of the Open Campus, and we will present you three texts that are covering our topic, which is NFT sales forecasting. Your turn, Can.
So my turn, thanks, Julian. Can you mute it?
Yeah.
Okay. So want to do the text set that mapping the NFT resolutions about the market trends, the trade networks, and the visual features. Next, please. They go through and four steps. The first one about the data distribution, talk about the statistical properties of the market in the different categories. The second one, they want to know about the individual behavior or the network of the trades. The third part, they talk about the visual features and expect a homogeneous signals. And the fourth, the last step, they did a price predictions of the NFTs, and the data they use for the price data on the transaction data in two markets, 80% for the primary sales, and then the rest belongs to the secondary sales, using 5 NFTs collections in 6 categories. Next, please. The first part about data distribution across the category, they classified into 6 categories, and they are differently in the distribution and also the size of the circle, showing the sales volume differently. So they observed the top categories belong to art, metaverse, and utility and power law functions is to observe the data distribution. Next, please. The second one, they want to know about the network of the trades, and they assume every trader as a node in a tree. So as the properties of the node, why they want to do it, because the individuals, the top 10% of the traders, they have the very high volume of the purchases and perform 80% upon transactions. And the more longer the traders in the market are, the better, the more purchase that they give. And the interaction between the pairs, the question is that whether there is any connectivity between the pair. There are several pairs, the buyer and the seller. They have the assumption that whether the buyer and seller have the same interest in the same collections, or they purchase across the collections. And the trader and trader, the results show that there are no connectivity between them. The trader tends to buy the sales NFT with the other trader in the same collections more than across the collections. And among the NFT and NFT market, they categorize into 2 collections, the small one and the big one. With the small one, the traders tend to buy in sequence with the other collections, more collections, differently collections. But for the large collections, they will purchase just the same collections, the same interest. The next, please. And then they extract the visual features. They are differently from cryptocurrencies and and the NFT because they have the visual features. They pre-train the model with the convolution network AlexNet and using the quotient distance to show the visual difference between the pairs of the pictures. That's interesting because they are not seeing look at just one picture, but they seems like individual pictures and compare the pairs of the pictures. So the idea that they want to map the images in the lower dimensional features, and they apply the principal component analysis to transform the network vectors in the linear combinations. Next, please. And lastly, they have the price predictions. They use basically the model, the basic model, linear regression for the primary and the secondary cells. They apply the secondary cells. It means that 1 month after the primary cells, and they show that it's more efficient if they use the preceding data from the primary cells rather than just pick up a sales for a longer purchase. And the features, they have 4 features or 4 variables to run the linear regressions. First, the degree or Bayes range centrality of the buyer and seller. The second one is the principal components of the visual features. The third one is the prior probabilities of the sales within the collections, and they use the base median price for both the markets within the same directions. Next. So overall, the properties of the market, there varies in categorical classification. The traders and the networks, the NFT network market traders are specialized, and NFT collection tends to visually homogeneous. That's what they expect, and the predictability of the prices. It seems like past data is the best predictor, and the visual feature takes very important to increase the predictability. And next, Julian will talk about the NFT appraisal prediction. So how about utilize the research, the train, the public market, or linear regressions?
Great. Thank you very much, Can. I'm assuming it's my time. So we will go through NFT appraisal prediction. It's another paper talking about predicting NFT prices. It's utilize search trends, public market data, linear regression, and recurrent neural network as different data sources. So a few words about NFT sales forecasting. It's a nascent market of 50 billion capitalization in US dollars. It has a high volatility and hazardous speculation, but it's becoming a key element of ownership in the digital world. So forecasting NFT value is important for individual financial security. And while NFT values is depending on weak signals like community of adopters, partnering with influencers, we consider that AI can help identifying good investments. NFT data, as there are more NFTs today than there were websites in 2010, indexing historical data from the Ethereum blockchain is tricky. They use Covalent API, which gathers data from multiple chains. So the authors collected data from Covalent API, and the data used are a date, price, average price on D-Day, the number of NFTs sold on the D-Day. So they have been crossing different sources and they passed it by various machine learning models. The first source used is the public market data, which has traditional investment metrics. Then they are concatenating it with NFT data, so the metadata properly of the NFT. And they are also using social trends data, the qualitative data such as sentiment and engagement metrics, which are converted in quantitative variables. And so these data are first passed by recurrent neural network in order to make some prediction of value using time series. And then they use a linear regression to identify the features that are correlated with NFT value and also reducing redundant data. So about the public market data, they have been using Yahoo Finance API to get all the tickers. Tickers are the traded share of a stock, and they concatenate both NFT metadata with this public market data. About social trends data, they have been quantifying qualitative metrics such as the hype using Google Trends data to track the search volume of a collection over time. And they also added something they added a significant event feature which quantifies the impact of news on the pricing. And so they created a variable that is positive or negative depending what's said on Google News about this or that NFT. So the first model they used were recurrent neural network with groove cells, and it is the one having the best accuracy with these parameters. So they have been trying different RNN and they retain this one as the one performing the best. But still the average percentage error is high. It has 18% of error on training, 168 on validation, and 185 on tests. So yeah, as you can see on the graph on the right side, we can see the data on real value in blue, and you can see the training prediction value in red. And yeah, indeed it's not bad, but it's not the best, especially it's not predicting the high peaks. So the researcher decided to pivot away from price prediction and look for which factors influence the price of an NFT instead. And this is how they used linear regression. So at the beginning, the model had 16 predictors, which happened to be very correlated to each other. They were sharing a high multicollinearity, which impacted the regression negatively. So after evaluation, they did reduction of feature redundancy, and they ended with four predictors only, which increased the model quality without losing any important information. And actually it happens that the average NFT price of the previous day and the daily volume of the NFT sold are the most influenced variables on predicting the NFT price, together with the Google trend, so the relative search volume, which is also quite significant. The fourth one is the gas rate of the day, which will explain why people buy or not on D-Day. So yeah, just a reminder on the course project, since we are trying to make NFT sales forecasting using visual features, yeah, we think that it will make sense to try to fix the sales forecasting for NFTs, since there are more and more NFT being sold, and that it's a matter of public importance somewhat to be able to build trustworthy NFT recommendation system. Malte, it's your turn.
Yes, thank you, Julian. So I dealt with another paper from 2020, which was an analysis of the features considerable for NFT recommendations. So at the end, we want to build this recommendation system, and they also tried and did in some parts well, in some there are still open questions. Can I go to the next slide? Thank you. So first of all, there are different value driving factors for NFTs. Of course, the right of ownership. Every NFT you have is a unique piece you have, so it's really the user really owns it. So there's not a copy. There's only one original. Of course, it's also supporting the creator. So when you buy an NFT, the money also goes, depending how much, but some of the money goes to the creator. Then of course the scarcity, so yeah, it's a unique piece, so this is also driving the value. And yes, you can also share or buy NFTs as a shared project, so people can from one NFT can buy a piece of it, and can own a piece of an NFT, which also drives value. In the paper they described that the demand is expected to drive the price rather than technical or economic indicators, but of course they also play a role. So on the next slide, I have one important sentence from the paper. Crypto has a founding tradition of emphasizing freedom and privacy. Maybe because of this prevailing culture trend, the NFT space does not have any recommendations system. So there are not much or not at all any recommendation systems, but there is a need for the creator, for the buyers and sellers. So we try to fix that or help with the improvement, and we focus also on the trades of an NFT. So on the next slide we have two different approaches. First, the trade similarity content-based recommendation approach. So there, the authors also looked how similar are the visual features of an NFT, and for us the question would be, can we identify defining features for successful NFT, for example a good price, with computer vision. And the other approach is the trade rarity-based recommendation approach. So there the authors say, okay, we have a successful collection of NFTs, but the user should be recommended the rarest of it. So because the rarest of one NFT collection, of course, probably drives the best value. So these two approaches always have to be together, but none of them can stand alone. So on the next slide, so our conclusion. So we want to build a reliable recommendation system as a combination of market mechanics, so history, sales data, and visual features of NFTs. The market mechanics, this is already done quite often with cryptocurrencies. So there we expect to have not as many problems as maybe for the visual features, because this is an approach which is quite unique and not done that often. So we probably have to build a model from the ground. Yeah, thank you for your attention.
Thank you very much.
You're still muted.
Yeah, thank you everyone. Bye bye.
Bye.